We'll continue on lesson 1.6 today with the same learning goal we had yesterday. I can solve an equation with 2 or more variables for the indicated variable. In other words, it's probably already solved for a variable, but they want us to solve it for a different variable that's in there. So some of them might only have 2 variables, some might have 3, some might have up to 4 or 5 different variables in there. We just have to follow the process, the rules of solving equations. So today we're going to maybe come across something that says when there is a fraction in the formula, first multiply both sides by the reciprocal of that fraction. Reciprocal. So we're going to get rid of the fraction basically. When we multiply a fraction by its reciprocal, we get 1. And 1 times something, we can kind of ditch that 1. So when we see a fraction, our first goal is going to be, what do we have to do to get rid of that? So here we have the volume formula, V equals 1/3 LWH. Anybody happen to know what that's the volume formula for? Let me remind you, yesterday we worked with the volume formula for a rectangular prism. It was volume equals LWH, length times width times height. That's the rectangular prism. No, it's not a square. It's not. First of all, a square is only 2-dimensional. This is 3-dimensional, and it's not a cube. It's not a rectangular prism. That's the one that's LWH. It's 1/3 times that. So guess what it is? It's a pyramid. This is the volume formula for a pyramid that has a rectangular base. So we're going to look at this, and it says they want us to get H alone, okay? H is the one that we need to have by itself. But the first thing we're going to concentrate on is that there's that fraction 1/3 in there. So anybody know what the reciprocal of 1/3 is? 3/1. So we're going to multiply both sides times 3/1. So 3/1 is going to start out our sides. Don't do it off to the side there and cram it in. Write it out like I did. Remember, we're never going to mess with it the way it starts. We always want to know how it starts. And our next line will be our work line. Okay, over here on this side, this 1 is really not important. We can kind of like ditch it. 3 times V is 3V. So we had to multiply that side also by that reciprocal. So the V now becomes 3V. Over here, these 1's cancel. These 3's cancel. And we're going to have just 1, which we don't need to write because 1 times 5 is still 5. 1 times 10 is still 10. 1 times LWH is still LWH. So we're not even going to mess with it. We're just going to write LWH. So multiplying by the reciprocal of that 1/3, got that 1/3 out of there. Now, it's the H we want alone. So what do you think we could do as our next step?
You would divide the L and W.
Okay. We don't want to divide by the H because we want the H to stay there. So we look at that side and we say H is being multiplied by LW. So we need to divide by LW. So we'll divide both sides by LW. Considering that it's the H we want alone. So that's how we made the decision. H is being multiplied by LW. So we need to undo that. And we accomplished what we needed to. The L's cancel, the W's cancel. Now notice, the only reason we get to do all this canceling is because there's just multiplication going on. If there were addition or subtraction going on, we'd have to be a little bit more careful. Can we cancel anything on the left side? There is all multiplication and like division going on, but can anything cancel upstairs or downstairs? No. So we're just going to have to leave that just how it looks, even though it doesn't look pretty. 3V over LW. 3 times the volume divided by the length times the width will give us the height. There's our pretty answer. H is by itself. That was our goal. So what if there had been a 1/2 there in the formula? What would we have multiplied both sides by? If there had been a 1/2 instead of a 1/3, what would we have multiplied by? 2/1. The reciprocal of 1/2, which is 2/1. Okay, anybody have any questions? So when you're working today, if you see anything that has a fraction, refer to this problem in your notes and see what did we do to deal with that fraction first. That's the first thing we want to deal with. Okay, sometimes you may need to undo the addition or subtraction first. Just like we did when we were solving multi-step equations with one variable, we would take care of the addition or subtraction first, and then we would undo the multiplication. And we're going to have to be able to do this coming up in a couple of chapters. We're going to have to be able to understand how to rearrange an equation and get
Can you go back?
Yep.
What was that last part? Then undo.
multiplication. So it says in number 2, solve y equals mx plus b for x. It's the x we want alone. What's alone right now? What's it solve for right now? It's solved for y at the time being. Y is by itself. We want that x by itself. So first thing we're going to do though is we're going to look on that side where there's x, and we can see x is being multiplied by an m, but it also has a b being added to that mx, doesn't it? And I said we're going to undo the addition or subtraction first. So what would be our first move here?
Subtract b from both sides.
Yeah, subtract that b from both sides. So we're doing the same thing on both sides. Can you really take y away from b? No, it doesn't turn into yb, because that would mean multiplication. So we write it just like this. We write it horizontally instead of vertically. Y minus b are not like terms, can't be put together. Bring down our equal sign. These guys took care of each other. The only thing left over there is our mx. Okay, now, remember it's x that we want alone. So what's happening to the x? Being multiplied by m. So again, don't show it in this step. Write this down again. Write this down again. We are going to do what to get that x alone? What? Divide by m. We're going to divide by what x is being multiplied by. Now, be really careful here. You either have to do it to every piece, or you can do it to the whole side. If you make a long enough fraction bar, you can do it to the whole side instead. So when we undo multiplication or division, we have to do it to every piece, or we have to do it to the whole side. So we're going to just leave it like that. Y minus b all over. Make sure your fraction bar is long enough to show that that whole side is being divided by m. And over here, the m's cancel out because there was no addition or subtraction going on. And we have x by itself. Okay? And that was our goal. So there's our not so pretty answer. Looked better than what we started with it, didn't it? Okay, now I want to show you another way that just possibly, in case it shows up like this in an answer bank that way, I want to show you that we could take each piece and divide it by m. So y gets divided by m, subtraction. B gets divided by m. Mx gets divided by m. That's one piece because it's multiplication. So do this with me. I want you to have this in your notes. Because what if the answer did not show up in the answer bank like that? Let's say you're taking a multiple choice test, and this is not how they show the answer, but you're convinced, you followed our notes, and you're like, I did what I was supposed to do. So what would happen? Well, y divided by m can't really divide it by m, so I'm going to leave it like that. Subtract. b divided by m. I can't really divide b by m, so I have to leave it like that. Equals, these guys cancel out because of the multiplication going on there. So that might possibly be another way. So I'm going to put the word or in here again. That might possibly be another way I would see that same problem's answer in an answer rate. Okay? So we either show that the division gets done to the whole side, or we show that it's done to every piece. And sometimes the reason that we want to make sure that we understand that it can be done to every piece also is they simplify that way sometimes. That's one of their ways of simplifying. So anybody have any questions on either of those on the front side? So what are we going to do when we see a fraction in one of our equations like this that has more than one variable and we got to solve it for an indicated variable? When we see a fraction involved in the problem, what's going to be our first move? Okay. Multiply by the reciprocal of that fraction. Okay, what are we going to do if we see the side that we want to get a variable alone? On that side, there's not only multiplication going on, but there's also addition or subtraction. What should we undo first, the multiplication or the addition or subtraction? Now, what do you think?
Undo the. Okay, so you said undo the addition.
So if we have, we're supposed to solve for an indicated variable. If on that side where that variable is, there's addition and or subtraction, one or the other, and there's multiplication going on, we're going to deal with the addition or subtraction first, and then the multiplication. Okay, let's go to the back and practice a couple more here. Okay, I'm convinced you can do that number 3 by yourselves. Go. Do it. Solve m equals t minus r for t. T wants to be by itself. What you've got to do to get the t alone. I'm going to give you a little hint. It's just one move. That's all you got to do. Okay, who wants to go up there and do it for us? Go ahead, Andrew. You can figure it out if you want. Just write with your finger because it skips with your pen. Your finger does a good job. Okay, thank you, Andrea. How about the rest of you? Is this what you got? You agree with her? Okay, so let's circle that answer then. It was t needed to be alone, r was being subtracted from t, so we need to undo subtracting with adding, and we don't have any multiplication going on that time, do we? So we don't want to invent things that aren't really going on. We just want to deal with what is really happening in that problem. Okay. Number 4, 2a plus 2b equals c. What are we supposed to solve it for?
B.
B. Is it solved? What's it solved for right now?
C.
C, yeah, C is by itself. So we need the b by itself. So we need to look on the side where b is. So it's b that we want alone. So we look over here and we say, oh, there's the b right there. What's happening on that side? So there's a couple of things happening to the b. What's happening? What's one of them? What's one thing happening? Seth, what's one thing happening to the b's? Okay, so the b is being multiplied by what? 2. Okay, so that's one thing. How about, is there anything else going on that side? Samuel, anything else happening on that side? Seth already proclaimed that b is being multiplied by 2, so it kind of sounds like we got to undo that, but is there anything else going on?
There's also
Just a minute, Adam, I'm calling on Samuel. There's also some a's, and what's happening with the a's? Well, but the a's are not part of, they're being added to the b's, right? There happens to be 2 of them, but they're being added to the b's. Okay, so we're going to kind of follow the same thought process we just had on the front. When there's a couple of things happening, what are we going to undo first? Should we undo that dividing by 2? Or multiplying by 2, which would be dividing by 2? Or should we get those A's out of there?
Okay.
Yeah, we said we're going to undo addition or subtraction first, didn't we? So we're going to take that. What would we do to get those A's out of there? Subtract them, yeah. So minus 2A. So we have to do it to both sides. Okay? So these guys are gone now, right? On that side. What do we have left? 2B. And then on the other side, what would that become? Just C minus 2A. We're not going to mess with it. We're not going to try and put them together because they're not like terms. Okay. Now what? Preston, you have a suggestion for us? What do you think we could do next? Remember, it's B that wants to be alone. What's happening to the B right now? Being multiplied by 2. So what do we do to undo that multiplying? Yeah, we need to divide by 2. So we say, you know what? Since 2B has to be divided by 2, that's our goal, to get B by itself. Since 2B has to be divided by 2, we have to do that on the other side. So one of our options is what? Divide the whole side by 2. Okay, that's an option. Now, listen very carefully to me right now. Don't be trying to do your own stuff. You need to really hear me on this because this is where we do something that we think we can get away with, but we really can't. Because there's multiplication over here, I can cancel these 2's because there's multiplication. When I come over here, I have a subtraction problem upstairs. That subtraction problem is being divided by 2. It's not a multiplication problem, it's a subtraction problem. Because that whole thing is being divided by 2. I can't cancel those 2's. I can't do this. So don't do this on your paper while I do it. You can't do that. No, you can't. Illegal, get you in trouble, won't get you the right answer, you'll get it wrong, you know, all those kinds of things. So what we have to do instead is we have to say, well, I got the B by itself now, that's what I wanted. I'll just leave my answer like that. So there is one possible way we would see it in the answer bank. So we got this multiple choice answer bank, and we work the problem out, and we look and we see, oh yeah, there's my answer. I think I got it. Or you get this answer and you go to the answer bank and it's not there. You think you're wrong now. So you're just like, well, I'm going to have to guess. No, you don't have to guess. We have another option. Or, oh, let's go up here a little ways. Or up here where we divided, well, the sides by 2. Remember, what's our other option? Instead of dividing the whole sides by 2, we can go look on the front. Go look at our board on the front. What did we do? Divide each part. Divide each piece by that. So the 2B is going to get divided by 2. The C is going to get divided by 2. Bring our subtraction. The 2A is going to get divided by 2. Okay, now you've got to be with me again. Stay with me. Because here's the deal. Multiplication, can I cancel those 2's? Multiplication, can I cancel these 2's? Thank you. Okay, bring my B down. C divided by 2, can I do that? Is there anything to cancel upstairs? No, no multiplication going on, right? C divided by 2 is just going to have to stay C over 2. Bring down my subtraction sign. Can I cancel these?
Yeah.
Why? Because there's multiplication. There's no addition or subtraction up here, it's just multiplication. So I can say, oh, I can cancel those guys. I can simplify that. And what do I get? A. Right? And that might be how I see the answer instead in an answer bank. So, we have to know how to be able to decide if we did it right, but maybe we just did something different than they did. Is there another way I could go about solving it and see if I get the answer the way they have it instead? So not every problem has this capability. Some problems, like the one up above, you know what? There's nothing else to do except, to get t by itself, add r to both sides. Don't have any other options there. Adding r to both sides is adding r to both sides. Okay? So anybody have any questions? Any of these we should go back to, because you're stuck on this stuff for a few days here. We gotta make sure we know how to attack it. Okay, taking out yesterday's notes, using these notes. Let's get out also a sheet of loose leaf paper, write down the assignment, and using your notes to get started on the homework.